right, everybody, welcome to DevHour. This is episode number 4 in our first chapter. We're going to be talking about Hibernate and entity management basics. My name is Jarmo Lindmark. I am co-founder of Everything, and with me we have Martin Bergstrand as well.
Yes, hello everyone. All right, so let's recap what we did the last session. In that session, we worked a little bit with automation and deployment. So we configured our Maven artifacts to actually work with versioning in a pipeline. We worked with GitHub Actions specifically to create the pipelines. We pushed our Docker containers to AWS in Elastic Container Registry. Then we created a couple of Helm charts to manage our deployments for us for the Kubernetes cluster. And then we actually deployed the containers into our existing AWS Elastic Kubernetes service using the Helm charts. And if you missed that session, feel free to just go ahead and watch it on YouTube. You can just search for DevHour. And we have also the previous sessions there as well. So if you want to come back later and watch it, that works as well, of course. So with that said.
Yeah, so let's get going. We are today going to be configuring our project to use Spring Data. Spring Data uses by default Hibernate as an implementation of JPA. We're going to create some entities. We're going to have relationships between those entities. Then we're going to talk about those different types of relations and caveats that you might find when creating them or when you're configuring them, because it's easy to configure them badly. And in the end, we're going to create some tests and we're going to run our code and see that everything works as we expect. And we're also going to show the database tables created. This is the diagram that we will be going through. So if you remember, we have 3 services. We have a product service, we have an order service, and a report service. So basically, I don't know if you can see my mouse, but the product service is going to be using a database that contains these 2 tables, product and product variant. The order service is going to have a little bit more database tables and relationships. It's going to have an order, it's going to have the order products, it's going to have a customer, and the customer is going to have a bunch of addresses. And in the end, we're going to have some reports. Here we only show a report that's like a base report, and then you have order reports. We're also going to have customer reports that are not in this diagram. So without further ado, let's just start coding. So what I've done so far is basically I copied part 3 to part 4. But yeah, so if we look at our database diagram, we see that we're going to start with a product entity. So let's start doing that. Here, first we said we were going to add our dependencies to Spring Data. And also we're going to be using in-memory database called H2. So I'm going to go ahead and add those dependencies to our home file. We're going to see that we've added these 2 dependencies. You probably want to see this bigger. So we added the Spring Boot started data JPA, and we've also added our H2 database that we're going to use both for test and for runtime for now. Just to be able to explain the basics first. So I'm adding these to the parent POM, which means that these other modules or our 3 different services are basically inheriting everything from the parent POM. So all of them will have access to Spring Data and the H2 database as well. So I'm going to start with the product service, and we're going to go ahead and add our domain package. And we're going to add our product class. And then we're going to use some DevHour magic to have a product class here. And I'm going to add my product variant as well. There we go. I'll just prettify this because we don't need the
full package name.
The full package name, exactly. So we're probably gonna make this bigger. All right, so looking back here, we have a product with an ID, a name, and a variant. We have a product with a name and ID and a bunch of variants. And then a variant, what does that mean? Well, a variant looks as follows. It's gonna be something that has an ID, it has a name, it has a price, it has a relationship to the product, and it also has a size. And what is this size, you say? Well, let me show you. First, I'm gonna do like this. And I'm gonna create class size. That is gonna be actually an enum. And this enum is gonna have small, medium, large, and extra large. Oops.
Oh, that was extra large.
Thank you. All right. So basically, for example, we're gonna be selling T-shirts in this shop. So the products are gonna be T-shirts, and a T-shirt can have multiple variants, where the variants could be like a name of a color. It could have different sizes, like small, medium, large, and depending on those variants, they can have different prices. That's sort of how we're thinking about it. All right, so how do I make this sort of a database table, right? Well, we need to start by declaring that this is an entity.
I think you need to reload Maven. There. Let's try again. So sometimes the ID doesn't really play nice when you add on the parent POM the dependencies. You usually need to reload the Maven dependency.
So how do you declare a database table? Is by simply naming your class, or adding the annotation entity to your class, and then your class must have an ID, and this ID is gonna be auto-generated using the strategy auto.
So what's the strategy here?
So here, what we're saying is that this ID is going to be a generated value, and then you can have different ways of generating this value. You can do it by code, you can let the database layer do it, you can let, in this case, auto is let the implementation do it for you. And I'm using UUIDs because this way we get a couple of benefits. One, we're not having sequential IDs like 1, 2, 3, 4, 5, etc. Which also makes our code sort of more secure, because this way we're not giving, like if somebody would start spamming some APIs that maybe have IDs, and then they find one ID that works, then they can easily say, okay, now I'm gonna try the next one, like 2 or 3 or 4, and find more and more and more information. When you generate UUIDs, they're completely garbage strings. And it's going to be hard to guess which one is going to be the next in the sequence, and so on. Let's see what other DevHour magic I have added for these. That was useful. So next, I'm gonna say that this column called name is actually not nullable, which means it's a required field. So we're adding constraints both to our okay.
That was a weird import.
Both on the Java level and and also on the database level. So this will be added to the validation, and this will be added to whenever we add something to the database, it's going to check that it's not null. And if it's null, it's going to throw an exception, which is a good thing. And here we are also going to add some more DevHour magic, where we're gonna start. This is gonna be our first one-to-many relationships. So we're saying that each product can have many variants, and this is also pretty apparent since it's a list of variants. As you can see, my compiler is not super happy because you have to do it on both sides of the relationship so that it makes sense for them, which you will find out soon. So what am I doing here? I'm gonna say, okay, one product will have many variants. It's gonna be mapped by something called product on the product variant side. So if I go to the product variant side, I have something called product there. So that's how they're gonna be related to each other. This was not supposed to be here. So then I'm gonna say to JSON to ignore the property product from the product variants. So in the case you would send product as a response as a JSON string, then it would include the ID, it would include the name, and it would also include whatever the product variant says. And the product variant says that it also has a product, and the product has a bunch of variants, and so on and so on and so on. So you can see the problem, right? So it's going to be like an endless loop, and your server is going to crash, and you won't understand why. It's like, oh, but I'm only returning like one product with one variant. Why is the server crashing? Well, it's because you have an infinite loop. So this is why we do these kind of things. What else? Well, as you can see, all of these things are private, so we need to add getters and setters. And I'm gonna do it by trying to be smart. Now, since there we go. I'm on a Mac, and I was used to it changes. I'm going to insert getters and setters for all of them, but I'm going to remove the setter for the UUID because I don't want people to add their own UUIDs. I want them to be auto-generated. And then you might ask yourself, okay, but if I don't have a setter, whenever I fetch it from the database, how are they going to set the ID to this field? Well, they are going to use reflection actually. So what you get back is actually a wrapped object. That is called a managed entity, and then they will set the ID that way for you, and this way you're protecting yourself from having anyone set their own ID and sort of try to influence what the database should have. Because everything that does not have an ID, everything that has an ID equal to null, means that it has not been persisted to the database yet, or that is on managed entity. And if something has an ID, that means that it has actually been persisted to the database and has been given an ID by this generator. There we go. Now, one thing to take into consideration when we're doing these kind of things, like set variants, is that each variant has a product. So we need to set this product for it as well. So let me use some DevHour magic. Set variants. So our set variance is now gonna look like this. And obviously now it's complaining, so let me just, I'm gonna add the getters and setters here. I'm gonna also call this an entity. Doing exactly the same thing I did over there, I'm gonna remove the set ID as well. at least now it's happy. So what's happening here? Whenever somebody sets the variance, we're gonna check if the current variants are not null, then we're gonna go through each of the variants and tell them, hey, your product ID is now null, because whatever you used to have, now you don't have anymore, because you're setting a new set of variants to this product. And then if that set of variants is not null, we're gonna go through each one of them and I'm gonna say, hey, Mr. Variant, your new product is this product. Done. And then we say this variant equals this variant. Then we might want to add also a helper method. Called add variant. And what does this mean? Well, it's basically just add one of those variants instead of setting all of them. So we're gonna get the variants, we're gonna add the product variant, and also we're gonna say, okay, now you product variant, you have this new product as your product. And then it's done. Then also, usually as a convenience method, we add we overwrite the toString method so that we can sort of print out what is represented by this object. So I'm gonna add that. And it looks like this. So basically, override the toString method and say, okay, I'm a product with ID, get ID, name, get name, done. I'm not calling the recursive product variant, because then we would get sort of the same problem if we would print them on both sides and so on. So if you want to print the product variants, then you would have to get them and print them on their own. Cool. So our product entity is ready. Now let's go to our variants and see what kind of DevHour magic we have here. Not that much magic, because we explain most of the things on the other one. So I'm just gonna go like this. I'm gonna show you what it looks like. Here we're actually using Lombok data annotation, which means that it's gonna have the debtors, the setters, and so on populated by you, so sort of creating a easier to read file. One consideration to take into account is that now by adding this, I'm actually adding a set ID here to this class. So this would be one reason why you would not want to use Lombok annotations in your entity classes, and actually go ahead and add all those extra methods. I'm gonna leave it there, because then that serves as a learning point why you should or should not add different random libraries to your entities. We're using the same generation strategy here. Automatically generate new IDs for these guys. It's gonna have a name, it's gonna have a price. This is gonna have a product. Here we have added that instead of one to many, as we had on the other side, here we're saying many product variants belong to one product. Cool. And it's not and it's optional equals false, which means that if you're gonna add a variant, it must have a product assigned to it. Like, you cannot add a variant without a product, because then it doesn't make sense. And the same concept there. We're telling JSON to ignore the property called variants on the product side, so that we don't have a infinite loop. And finally, we have an enum called size. And size, as you saw, is small, medium, large, extra large, which is pretty cool. But if we don't add this little annotation to it, then when we save them to the database, instead of saving it as SMLX that you would read in that column, it would say actually something like 1, 2, 3, 4, or 0, 1, 2, 3, I'm not sure. So it would use the index of the actual value to set it in the database. And what problem that might lead to? Well, if somebody decides to M is not going to be here anymore, now it's going to be here. then suddenly you have changed the order of all the things, and that means that their indexes have changed, and then that also means that all the database, all the information in your database is garbage, because now nobody knows which one is the correct one, which one was saved with the new version, which one was saved with the last version. So obviously you could have a rule that says, oh, do not change the order of this, but we all know that things happen and people will change it, and then you'll be stuck. So instead, we say this is an enumerated field, and we want the value of the enum to be the string value of the enum. So basically, whatever the variable is called, that's the string. So we're going to use S, M, L, and XL in the database as values. Pretty cool. Same thing here. We're overriding the toString method to sort of print what this is all about. Cool. But Jarmo, how do I add them to the database? Or how do I read them from the database? Well, in Spring we have something called repository. So I'm gonna add a package called repository. And here I'm gonna add all the repositories I need. I'm gonna add another Java class, which is gonna be an interface called product repository. It's like pretty self-explanatory. Did somebody have a question?
No.
Okay. So I'm just gonna start like this. I'm gonna say that this is a repository. I'm gonna say that this extends something called JPA repository, which takes in there we go. Which takes in a product, and the ID of that product is a UUID. And by just extending this JPA repository, we are going to go into that, and we can see that it has added a bunch of stuff. It has find all, it has a find all sorted, it has a find all by IDs, save all, flush, save all and flush, delete, get one, get by ID, etc. It's also extending a paginate and sorting repository, and the query by example executor. So the paging and sorting repository actually adds methods that let you use a pageable to your find all, which would mean that instead of getting all the results, you would only get that first page or the second page or the third page that you're looking for. Same with the sort, you'll be able to sort it out. And then yeah, in the end, everything is a CRUD repository, which extends repository, and you can save, find, and all these kind of activities. So suddenly, just by adding one half line of code and one annotation, we can start saving things and getting things from the database. So how do we do this? Well, let's create a test for that. So I'm creating a new test called product repository test. I use Command-Shift-T, or in Windows is Control-Shift-T.
Zoom in a little bit, John.
I will zoom in a little bit. And then you can see that it has created a class in my test packages with the sort of the exact same package as my repository class. And it basically has the same name as my product repository, but it adds test in the end. Product repository test, and it's in the same package. Pretty cool, but it's in the test resources. Okay, so a couple of things we need to do. First, we need to make this class public. I don't understand why they keep making it not public. And then we need to tell it that this guy is gonna be a JPA test, right? Or a data data JPA test. So we add this annotation. With this annotation, now we have access to something called a test entity manager. And while I write this, Martin can explain to us what the entity manager does. And
Sure. So the entity manager is the one that handles to actually start the transactions toward the database and convert your code into SQL, more or less. Very simply put. So it's responsible for yeah, everything you want to get into the database, more or less, and retrieve from the database as well. Very simply put. It's a lot more magic to it, of course, but that's what you really need to know.
yeah, so okay, so now I have sorry, added that test entity manager, which is basically an entity manager like Martin was explaining, but it's used for testing. So it will pop up a new database. It will populate the database with the tables that we have declared based on our entities. It will then run our tests, and in the end, it will also tear down all the data and the database that was created, and then everything is empty for the next one.
So, and that's our product repository.
Yeah. For some reason I called products. I'm gonna rename that. I won't. I'll keep it like that. Let me just import some of these methods. I am using a search core API. It's pretty useful. So, okay, what am I doing? I have my entity manager, I have my products, and I'm gonna test the find all. So I create a new product, I set its name, and then I add a variant. It's called getVariant. That calls this method getVariant. That's down here. That basically creates a variant with that price and the size that I've told it. Right? And then I use the entity manager to persist, basically save to the database the product. And then I list all the products. I say, hey, product repository, find me all the products. I get those back. I check that the size is equal to 1 because I have saved one product. Then I get the first result from there because now we know that it's only one there. So I get the first result, which is my product that I saved. I check that the ID is not null because if you remember before, we said that if something does not have an ID, it has not been persisted to the database. If it has an ID, it means that the ID was generated successfully, and now it's been persisted into our database. Then we're going to check that the name is there, and we're going to check that it has 3 variants, right? Because we added 3 variants, small, medium, large.
So what does persist mean?
So persist means save to the database.
Is that using transactions or?
This is using a transaction that is on the method basis here because we're running on a test. And what it will do is it will, let's run it and I can show you because we will see that first of all, this test is going to fail. Let me enable annotation processing. There we go. Since we added Lombok, we need to add annotation processing for it to be able to understand that, though it actually has those getters and setters. So now that I run the test, you will see that it's actually popping up the actual container. It's starting up Tomcat, and now we got an error. And the error was in this line 46, which is that the ID of the variant is null. Because we're saying check that it's not null, and it's saying it's null. So let me see if I can zoom in here. Yes, I can. Good, great. If you can see in the output of this test, we can see that Hibernate, we're using Hibernate by default. We never even added any dependency to Hibernate, but as I mentioned in the beginning, Spring uses Hibernate as a default implementation unless you tell it otherwise. And it's going to insert into product, and the product has a name and an ID, and with these values that we don't see here. Great. And then we're going to select all the products from product. cool. So it's basically doing what we're doing, but it actually never inserted our variants. But we said that it had 3 variants. What the hell is going on there? Well, if you remember over here, I removed something from this many to one. And that is something, sorry, I'm in the wrong class, from this one to many. And this is basically something that most people do that you probably shouldn't do. And this is cascade. And I'm gonna say to cascade type all, and I'm also want to remove the orphans. So what am I doing here with this cascade? I'm saying whatever I do to this product entity, I want you to do the same thing, or i.e. cascade, into the variant as well. So if I save a product, I want you to save the variant and so on. So basically any operation that I do, right? You can do detach, you can do merge, you can do persist, you can refresh, you can do remove. I want all of them. That's because it's easy. And then this orphan removal equals true. What that does is, if by some reason you would remove a product, it will also remove any of the variants that don't have a parent anymore, which the parent in this case is the product. Okay, so let me run the test again and see what happens. Well, now our test is happy and green. So what happened here? Now we're actually inserting the product, and then we're inserting one variant, inserting another variant, inserting another variant, and in the end we're fetching the product, and the product now has all those variants, and those variants have their IDs because we have inserted them into product variant. I will revisit in the next session why you might not want to do a cascade type all here. And usually what you would instead do is have the product repository only take care of products. And then you would have another one, or another controller, where you would say, hey, add this product variant to a product, because you would not create a product variant without the product already existing. So that's usually how you would do it instead of cascading like we're doing here. So this is sort of like the lazy man's way of doing it. It usually leads to a lot of problems. So consider, if you are writing this, if there are better ways of doing it. And you will see this in the next session. Okay, cool. Jarmo, what else can I do? What if I want to find this product by name, for example? Well, by the magic of DevHour, I will show you. Why did I do this? I can find them by name. So I basically add a method called find by name. In Spring Data, you can basically add something called find. And it will give you, your IDE will give you options of, okay, what can you do? You can find by name, you can find all by all, find all by name, find product by, find distinct by, and so on. It's like it gives you ideas of what else can you search for based on what you're typing. So find by name, and you can do find by name and something else. And in the end, this is gonna return one product that it's optionally there or not, right? Because it might be that it found nothing with this test product name. Yeah, test product. Let's call it product. Just call it name. So find my name. Okay. Let's add a test for that as well. Boom, find my name. There we go. So what are we doing? We're we also added this test annotation. I don't know if you noticed, I think I missed it. But this test annotation is what's basically telling the test runner that this is also a test. Find by name, I create a product, I persist it like we did before, and then I say, hey, find this product by name, and the name is going to be test product as I had set it here. Does anyone see any problem with this? Maybe potential problems or something that doesn't make sense by doing this? Like, why would you want to find by an exact name, for example? After I got that product, I assert that this product actually is present, so the optional is not empty. So now I can safely get the product. I get a persisted product. I check that the ID is not null, and I checked that yes, the name is actually equal to test product. So I save a test product, I find the test product, and I check that what we got back is actually the test product. I'm gonna run this test.
What is on?
Wait on.
So I think can't do much more than this one. Can save the others for learning and just put.
There we go. So it's inserted a product, our variance as it did before. It selected the product where the product name is equal to test product. And we got a product back and it was actually equal to test product. What you would usually want to do here instead of find by name is like something like find by name like test product or just test, and then you get anything that's called test back as well. So instead of an optional of one product, you would get a list of products instead, which might be empty or which could have a bunch of products. We can play around with that later. Let me do some more DevHour magic. Find by size as well. All right, so now we have a little bit more complex query. So now we actually want to say, hey, find me the products by its variant size. Which means that, okay, now we're not actually querying on the product, we're querying on one of the product's properties. So what does that look like? And can it be as simple as what we've done here? Well, it actually can be as easy because we can say find by and the name of the variable, in this case it's variance, and then we can use something inside that variant, some property inside the variant. In this case, we're going to use size. So I'm going to try the autocomplete again. You can say, you can even search for a particular size as well if you wanted to. You can do variance.size, or you can do variance.sizeXL, and so on. But we want to find them by all types of variants, which means what type of sizes. So which means that we send in the size here, and then we should get back. In this case, we're just gonna look for the variants that are of size M. We check that prods is not empty. I guess we could assert that prods.size is equal to 1 because there's only one medium-sized chart there. I'm gonna run the test as well.
So most of the magic seems to be in the repository provided by Spring Data.
Yeah, exactly. So as you saw when I was going through the repositories, by just extending that one class, we're getting so many things for free. And then Spring Data on top of that has its way of understanding that, okay, if you write things in a particular way, then you're gonna get the results that you're expecting. So same here, we insert the products, we insert the variance, and then we select from product, and we also join with the variance table, and we say where variance.size equals the size we're looking for. So it's actually making a join by us simply telling it to, hey, find by variance size. we have 10 more minutes. There's a lot more to see, as you can see from our slides. So the order and the order reports and the customer reports. We are going to commit and push that code. I can show it to you quickly here on my already finished example. Same concept there. We have a domain where we have our different entities, address type, a customer, an order. An order has a bunch of, each customer has, or an order has a customer, which is a customer can have many orders. One order can have many order products. You can have one payment type. You have a subtotal, a tax, and a total. And we're also adding Sunday types that are timestamps for when it was created and so on. We have a bunch of repositories as well. So we have the customer repository, we have the order repository. We haven't done any special queries for those. We're just getting all orders, or we're just getting all customers, or we're getting one by ID. We have added tests. We have not added tests, but it's going to look the same as the other tests. We have the report service over here. This one is adding a concept that we haven't seen before, which is the fact that we're adding inheritance. So there is an abstract report entity that has sort of values that all reports are going to have. They're all going to have an ID, and they're all going to have a report type, and they're all going to have a date that they were created. And then we have an order report that has a method that returns what type are you, and this is an order. And the customer has a method that says I'm a type customer. As you can see from this abstract method here. We're saying also that they're going to inherit. It's going to be table per class inheritance, which that means that each one of these entities is going to have its own class instead of being all in the same sort of class with multiple columns that don't belong to one another.
How does that look in the database? Will it be multiple tables or one table?
Yeah, so exactly what it means is that order report will be one table and customer report will be another table. But they're all reports. So here in the report repository, we started with our report repository, but then we figure out that, okay, we also need an order repository for finding only orders. We need a customer repository for only finding customers, but what if we want to find all repositories? So we added a report repository, and we also added a sort of helper query method that maps all of the reports by grouping them into their report type. So then we're going to have a map back with the report type as the key and the list of reports of that type as the value. And I'm going to show you quickly the test so you can sort of understand what I mean. There's a lot to see here, but I'm just going to jump all the way down to the final map. So by persisting the reports, it basically creates a customer report. Let me make it bigger. It creates a customer report, it creates an order report, and it persists both of them. Then we're going to say, find me the map of report types. We check that it's not empty. We check that it actually has two values. So one customer, one order. And then we check, okay, map, get me the orders. Check that its size is 1. Map, get me the customers. Reports, check that the type is 1. And then I'm also printing the key set just so you can see what it's there. Just going to run this quickly before I show you what the database looks like. Sorry. Same concept here. It inserted a customer report, it inserted a order report, and then it does this mapping from the report creation. So it's actually joining all the tables. by union, and then we're mapping them. So order and customer as the different types that we have there. And I think this is the end, apart from that I wanted to show you. Let me just start any of the services up. Let's start with the product service, or the order service was a bit more complex. I'm just gonna run this application. And here you can see a couple of things that we have: Spring Data repositories. It's in default mode. We're running Tomcat. We have started the H2 console, which is the in-memory database that we're talking about. It tells us how to connect to the database here. And it also told us which path it was going to be. It was going to be /H2 console. And here that we started on port 8082 with the context path /order. So let me just open up my browser. Sorry. With a new window, I'm gonna go to localhost 8082 order /H2 console. If we're lucky enough, it will present us with the database repository. I'm pasting the JDBC URL that I got from the log here, using the default username and password, and then I can see that it actually created order products, customer order, the customers, the addresses. So just by adding a couple of dependencies and annotating some classes, bam, I have a database that has the right type of things that I wanted with the right names and so on. And now we are out of time, but if anybody has a question or something like that, I am here to answer those. And if not, next session, what we're gonna do is we're gonna see, okay, so now we have created a bunch of services, and each of those services has a database. But now how do we actually in production add things to them, modify things, access things, read things, and so on? So next session we're gonna add API calls to all of our product services, and we're gonna have them talk to each other and fetch things from each other and so on. So it's gonna be quite interesting session. We have run out of time. It seems that we don't have any more questions. So thank you for joining, guys, and we'll see you next session. That we're gonna take a little break during the summer, so this is gonna come out in the probably beginning of end of August or beginning of September. Thank you very much.